De Sitter's observations were of what's known as a binary star system. Now, a binary star system has, as you might guess, two stars. And these two stars orbit around each other. More precisely, they orbit around their center of mass. These orbits often are very small radius, and also very fast. And so what De Sitter did was look at the light emitted from these stars at different points in their orbit. So for now, let's just pay attention to star 1, and just ignore star 2. So we know that if it's going around this way, well, at this instant in its trajectory, its velocity would be pointing in that direction. Eventually, the star is going to make it all the way around here, and its velocity will be pointing in exactly the opposite direction. Now, if the speed of light were not constant in all reference frames, if you really could throw light forward like a baseball, then when we looked at this light on Earth, we might expect to see some strange effects. I'm actually going to let an animation speak for me on this one. So here we have our one star of our binary system, and it's making a circular orbit. Now, at this upper point in the orbit, we can see it's moving away from this detector over here. At the lower point in its orbit, down here, it's moving towards the detector, giving more additional velocity to the light. And if you look over here, you can see that that light, which was emitted at the lower portion, actually overtakes the other light that was emitted earlier. This would lead to some really strange observations. So, for example, at some point, when this and this light arrive at the exact same time, light from the bottom and top, well, that means we'd be seeing the same star in two places. And it turns out, De Sitter found that that doesn't happen. This was a very clever experiment to confirm experimentally the second postulate of special relativity.